We are machines. The way we work, the way we think, the way we act were due to tiny machinery inside of us. And that machinery you can understand piece by piece, step by step. That's what we're doing in molecular biology. That's what we're doing in genomics. That's going to be the research for the next 100 years.
We've been battling cancer for centuries. There are so many thousands of rare genetic conditions. We're discovering new ones every day.
One of the biggest challenges I see is that the size of these data sets now surpass the ability of humans to analyze the data.
Can you store the data? Can you organize it? Can you manage it? Then you've got to think about how you compute over it.
So thanks to continuous advances in computing technology, it's possible to rapidly generate massive amounts of research and clinical data.
We can only understand genomes, how they work, what their impact is on human health, if we can compare a lot of them. We have to understand all of the differences between human genomes that exist in the population and how those are related to differences in outcomes.
When working with data at this scale, it is very difficult to collaborate on projects that span multiple institutions.
And it's a great technology challenge, and it's one that lends itself very well to cloud architecture.
Scientists who work on particular diseases aren't typically located in the same place. Without the cloud capability, they would literally have to ship disk drives around the world. One key challenge in analyzing these very large data sets is the time it takes to perform the compute and analysis on them. Sometimes those analyses using local compute resources can take days to weeks. Employing the power of elastic computing in the cloud often allows researchers to get to their answer quickly and move on then to the next problem.
We've seen significant improvements in performance through code optimization.
Cloud computing is a great enabler of a lot of science because it allows people to get access to professional computing in a secure way, on demand, easily.
When patient data is involved, security is always going to be a concern.
You don't actually want to have a situation where those data are moved around all the time. You want them to be available in a safe but replicated way, and then perform your analysis in the cloud without downloading that to your home institution.
I think one of the biggest advantages of adopting cloud computing in clinical and research environments is a clearly focused delineation of responsibility for security. Commercial cloud vendors can focus on providing secure building blocks, and the customer can rely on the cloud so that they can focus on security aspects that matter most to their applications.
Understanding cancer at the molecular level, we think, is radically going to change diagnosis and treatment.
We have patient advocates that want to get their patients' genome sequences out there and have all the bright minds looking at them and cracking their particular disease.
It's just a privilege, really, to be part of a community that has innovated so fast and is affecting so many people via our understanding of living things around us.